Hello, I'm Sri from CBTU. CBTU presents a course on Python language, section classes. Agenda for this session. Learn about Python classes, objects and their features, class definition, class objects, instance objects, method objects, class and instance variables. Class definitions contain statements and function definitions. Class is like a blueprint, prototype, and objects are instances created from class. When a class definition is entered, a new namespace is created and used as the local scope. Thus, all assignments to local variables go into this new namespace. Function definitions bind the names of the new function here. Python classes provide all the standard features of the object-oriented programming, OOP. Class statement defines a block of code and attaches its local namespace to a class for use in object-oriented programming. Def statement defines a function or a method. Object is an instance of a class which supports two kinds of operations: attribute references and method references. To instantiate, import the Python file or the module containing class attributes and methods. X is class1.c1, x.i is attribute reference, x.f1, this is method reference, x.doc is also attribute reference. Let us enter Python shell. Let us import class 1. Class 1 contains this sample test class. Let us instantiate class C1. Let us access class attributes. x.i, this is attribute reference. x.f1, this is method reference. Functions and classes are called methods. Text inside the triple quotes is docstring. It will be accessed with the doc attribute. Calling a class object may create an empty object or class object instantiated with initial state. When a class defines init method, class instantiation automatically invokes init method for the newly created class instance. Let us see an example. This is init method. Init method may have arguments which are passed to the class instantiated. We have init method defined here with arguments. Let us see this example. Python shell. Let us import class 1 containing class C2. Let us instantiate class C2. So this has type error. Init2 is expecting two arguments. Let us instantiate again. Now x.a is 5, x.b. The class is invoked with the parameters that were supplied. Class variables for attributes and methods are shared by all instances of the class. Instance variables are unique to each instance. If class variables involve mutable objects such as lists and dictionaries, they can be used to update by all instances. If same is defined in a function, it will be instance variable and not shared by all. Let us see an example. In this example, we have CV class variable and FV function variable. Class variable is same across all the instances and function variable is unique to each instance. Import class 2. Let us instantiate class C1. Type error. This class has init method and is expecting an argument. Let us input. Let us have another instance. Let us access attributes. x.cv, this is class variable, and x.fv, this is method variable. So y.cv, this is class variable, y.fv, This is instance variable. We can override these class variables also and make them unique for each instance. We can override these class variables also to make unique for the instance. Let us say x.cv. Now x.cv will output the new assignment. It has overwritten the class variable. Python provides all the standard features of object-oriented programming, OOP, inheritance and multiple inheritance supported, allows polymorphism, derived class can override any methods of its base class or classes. A method can call the method of a base class with the same name. Like modules, classes are created at runtime and can be modified further after creation. An object can be used for any type and it will work so long as it has the proper methods and attributes. Everything in Python is an object, including classes, functions, numbers, and modules. Python supports metaclasses, an advanced tool for enhancing classes functionality. There's a limited support for private variables using name mangling. We can define function outside the class. Any function object that is a class attribute defines a method for instances of that class. It's not necessary that the function definition is enclosed in the class definition. Let us see an example. We have function defined outside the class. In the class, we are calling this function and defining another method. Let us see import class 3. Let us instantiate this class. Let us see dir. We have f1 and f2 methods of class c1. This function takes two arguments, integer arguments, and returns the minimum of the two. We have another method f2 defined which returns a string. Import class 3 which has this class 1, instantiate class c1, q.f1 supply the two integers, it calculates the minimum and returns the minimum integer, and for f2 and just call f2 and returns this string. This is defining some properties, get, set, and property. Python allows the creation of class methods and static methods via the use of @class method and @static method decorators. The first argument to a class method is the class object instead of the self-reference to the instance. A static method has no special first argument, neither the instance nor the class object is passed to a static method. Objects with multiple names, alias, point to the same object like pointers. Some notes of OOPs. When we first describe a class, we are actually defining it with functions. Encapsulation is the ability to group similar functions and variables together. The word class can be used for a class as well as for the instance. Inside a class, a variable is known as an attribute and function is known as a method. A class is known as a data structure. It holds data and the methods to process that data. This is about basic understanding of Python classes. In the next session, we will see the inheritance of Python classes. Thanks for watching.